Okay, good afternoon, ladies and gentlemen. So, our objective for today is the same as yesterday. It's that students will be able to apply the rules of exponents to simplify expressions. So, we're basically continuing where we left off from yesterday. If you didn't do that lesson yet, you want to make sure you go back and do that one. All right. So, yesterday we learned about the product rule and the quotient rule. Right. Today we're going to go over two more rules of exponents. We're going to go over some examples to understand them and then apply those rules. All right. So first thing we're going to do today is something called the other product rule, right? So we're looking at examples like this where we're multiplying together two powers where the base is different, right? So this example here has a base of 2, this one has a base of 5, but the exponents are the same, right? 3, 3. Now, this is different from what we saw yesterday. Remember the examples from yesterday had the same base, so the base was the same in this case, but the exponent, 3 and 2, were different, right? And we go about solving this slightly differently. You need to know the difference between the two. So first thing we're gonna do is go ahead and write these out in expanded form, right? 2 to the third power simply means 2 multiplied by itself 3 times. And then all of that gets multiplied by 5 to the third power. So I have 3 5s. 2, 3 5s, right? Now, you might look at that and say, okay, Mr. Correa, that does not look any easier, right? It's not as simple as before saying, okay, now I have 6 2s or 6 5s, they're still mixed up, right? What you need to do next here is use a property of multiplication that we should be familiar with that's called the commutative property of multiplication, right? So, quick example, right? For example, I can say, I know that, for instance, 2 times 3 is the same thing as 3 times 2. Those quantities are equal to each other, all right? And we call that the commutative property, which means that you can move things around. So I can, in essence, use the commutative property to move some things around here, right? So I'm gonna start with the first 2 multiplied by the first 5. So 2 times 5 multiplied by the second 2 times the second 5. And then I have the third 2 times the third 5. Right? So you can see I have the same number of things being multiplied, but all I did was I changed the order. Instead of 2 times 2 times 2 times 5 times 5 times 5, I have 2 times 5 times 2 times 5 times 2 times 5. So I'm pairing them up with each other. Now, again, you're saying this might just look more confusing. Why are we doing all this? Now, I'm just gonna add some parentheses in to show you how this actually makes it easier, right? So let's say I put parentheses around the first 2 times 5. And then I put parentheses around the second. Remember, multiplication is commutative, so I can do all of this here. It doesn't matter what order I multiply things in. So let's go ahead and multiply together the things that I have in parentheses there. So what that gives me is actually 10 times 10 times 10, right? So right now I have the same base being multiplied 3 times. So I can now say that that is actually just equal to 10 raised to the third power, all right? So I'll do the next one for you again, just to help you with the idea here. Then you're gonna follow along on the next 2 examples. 5 squared times 6 to the 5th. So that's 2 5s multiplied by 2 6s. So doing the same exact thing we did before, I'm gonna rearrange them. So I'm gonna alternate between the 5s and the 6s. So 5 times 6 times 5 times 6. Whoops, a little typo there. There we go. Now, I can next step add the parentheses in, but let's just actually add the parentheses in right now. I know 5 times 6 is just equal to 30. So that's really just 30 times 30, which I now know is equal to 30 squared, because I have two of them, right? I want you to try this same exact approach for the next two questions, the next three questions here, and then you're gonna write out in words what you see is happening when you multiply two powers that have the same exponent, right? Try to be specific, try to explain how you go from what you start with here to the end result. Make sure you're using vocabulary like the words base and the words exponent, and explain what's happening with those numbers, right? Then once we're in the Zoom session, I will give you the actual rule to help you out with that, okay? Then we've got some practice on the next page right here. So you're gonna go ahead, practice this part here. If you're watching the video, you might wanna pause it, practice this first before watching the rest of the video, right? Second rule we're doing today is something called the power rule. So instead of having two bases like we had yesterday and today so far, we have the same base, but we have multiple powers. So it's a raised to the m power and then all of that raised to the n power, okay? So what it says here is that Penelope says she can use the fact below to try and re-express this. She's saying that she knows that 2 to the third power squared is equal to 2 to the third power times 2 to the third power. So I want you to just first think about that. Do you think that makes sense? Where do you think she's getting that from, right? Pause the video, think about that before I give it to you, right? Now, the way that she got that is just thinking about what it means to square something, right? For instance, we talked about the formula for the area of a circle and it had something like r squared in it. And remember, we said that r squared was just equal to r multiplied by r, right? When you square something, you're multiplying it by itself. So if you're squaring the quantity 2 to the third power, that's really just saying take 2 to the third power and multiply it by itself. So if you have 2 to the third times 2 to the third, now you should be able to simplify that just like we simplified things yesterday. So I want you to explain that in words. If you can, use whatever rule you know to explain that, all right? Then I'm gonna show you one example here on how this is actually done, and you're gonna practice the rest yourself. So 3 squared squared. Just like the example up top here, the way that I would re-express that is I would just say that that's 3 squared times 3 squared. And then to actually go ahead and simplify this, expand it, just like we've been doing. 3 squared is 3 times 3, right? 3 times 3 multiplied by another 3 squared, which is just another 3 times 3. And then writing all that in exponential form, all I need to do at this point, like we did yesterday with the product rule, is count up how many 3's I have. So that's 3 raised to the 4th power. Now, I want you to try the same exact thing for the next 3 questions here. Do the same thing we did before. In your own words, try to describe what's happening when you raise a power to a power. So what happens to the base? What happens to the exponents? And then try this rule yourself, or I will give it to you to tell you what you do with these during the Zoom session, right? Lastly, a couple of more example problems below. And again, the idea with this section is try to go straight from this section to this section without having to expand it out first. If you still need to rely on expanding it out first, you can do that. But the end goal is to go straight from here to here once you understand how the rule works, right? There's some push yourself questions, extension questions on the last page as well, right? Good luck. I will see you during the Zoom session.